Hey all, today we're going to talk more about proportions, but we're going to talk about some special proportions that exist in triangles um, when we have some special lines or line segments. So quick uh, reminder, proportions are two equal ratios or fractions. We've been using them when showing triangles are similar or when we know triangles are similar, but just a quick reminder that that's what it means to be a proportion, two fractions that are equal. So we talked about angle bisectors a while ago. We constructed them. And so when we have an angle bisector in a triangle, we have some special proportions. So this is my angle bisector. I know it's an angle bisector because this angle over here gets cut into two congruent angles. And so we have proportions created. There's a whole bunch of proportions we can write, and I'm going to try and just show you the simplest one. What I like to do is to draw my angle bisector a little bit longer. And so I can see this segment is getting cut into two parts. And when I look at this, it sort of looks like a fraction. It sort of looks like question mark over 15. And then these two sides are getting split by this angle bisector, and it sort of looks like a fraction, 10 over 25. And so that's a proportion that exists because of this angle bisector. And now once we have a proportion written, we solve it just like we've been solving proportions now for the last couple weeks. Cross multiply, simplify, and solve to get this piece to be 6. So let me show you another example. Again, I like to extend or maybe darken in my angle bisector, and I sort of can see fractions begin to form, 21. And if I look at my angle bisector sort of as that fraction line, I've got 21 over 12 and question mark over 20. If I set them equal, I have my proportion. And then again, it's just like we've been doing, cross multiply, simplify, and solve. I want the missing side of this triangle here, question mark, to be 35. Let's do one more. Again, I'm going to do the same thing. Extend that angle bisector. It looks like if I have fractions. This one might be a little bit harder to see because the fractions are sort of sideways. So we could write our fractions a different way if we want to as well. We can just draw a line across and write these fractions as well. But I'm going to stick to my pattern. So if I've confused you drawing another line, just use this pattern. I've got question mark divided by 8 and 15 divided by 6. And now I'm just cross multiplying and solving. Get my missing piece to be 20. So like I said, there's a whole bunch of different fractions we could actually write here, different proportions. But if you want to stay consistent, extend that angle bisector line and use it as a fraction bar to write two different fractions. The process is going to be very similar if we just have a line that's parallel to some other lines. So there's a couple ways to do these kind, and so I'm going to show you both. So here I just have 3 parallel lines, and I have 2 transversals, and so this middle parallel line I'm going to go over just like I did with my angle bisector. So this parallel line in the middle cuts this transversal and this transversal up in a way that we can write fractions that are equal. So I'm going to do it just the same way I did with the angle bisector. I have question mark divided by 6, and then 6 divided by 4. So I'm using that middle parallel line sort of as a fraction line. And then it's just solving a proportion. I'm going to go a little bit quickly through the solving part because we've been doing this for a while. Setting up the proportion is the new thing, and then solving is something that we've been doing. Here I don't have an angle bisector. I'm not cutting an angle in half, but I do have a line going through my triangle that's parallel to this one side. So I'll go over that like I have been doing. And so I have question mark divided by 25 and 8 divided by 20. And I have a habit of trying to put the question mark or X or the thing I'm solving for on the top of my fraction. That's not the only way to do it. I could do 25 divided by question mark and 20 divided by 8. I just think it looks nicer, and it probably looks nicer to you to put that question mark on top. It's important that the numbers on top of the fractions come from the same side of this line that I have. So if question mark's on top of this fraction, 8's got to be on top of this fraction. And so if you solve that, you get question mark to be 10. This one's a little bit different. I have my line going through my triangle parallel to my side, so I'm going to go over it like that. The problem here is I don't have anything written right here. And so there's a couple ways to go about that. I'm going to show you the way I think is easiest. There is a relationship that exists between this whole side of the triangle and this one. And so right now I have question mark as my whole side of the triangle. And so I can actually write a fraction between that value and the number below this line. And so that means my other fraction coming from the other side of my picture would have to be this whole, this whole side of the triangle and this piece below this line. So again, since I don't know this piece, I can't just have a simple fraction here. I'm going to use my whole side and put it in a fraction with the piece that's below the red line because I know that. So I'll use this whole side and put it with the piece that's below this red line. So what I end up with is question mark over 35 and 36, 20 plus 16 over 20, the piece below this red line. Okay, I chose the piece below the red line because that's what I chose over here. And now we're solving and we get 63. Let's do one more similar to that. I got my middle parallel line that I will draw this line across. I don't know what this piece over here is. I don't know what this is. But I do know how far it is from that right parallel line to the left one. I do know this length. It's 18. So I can write a fraction using question mark and 18. So I have the piece of this line over here below the red line and then the whole thing. And so I want the piece below the red line over here, and then I want the whole thing. So the whole thing here is 8 plus 4, which is 12. So I get question mark below the red line divided by 18, the whole thing, 4, the thing that's below the red line, and then 12, this whole piece, these two things added together. And I come up with that missing piece as 6. So I've got 3 of these for you to do. I put 1 on each page. Hopefully it's easier to see that. Use the examples that you should have copied down that we just went over. We'll answer the questions in class. If you have any struggles, make sure that you ask me some questions when you're given the opportunity. Make sure you watch to the end. There's one more now after this.